Okay, sorry about that. My little flip camera ran out of battery, and so I have to. This is just a continuation of where we were. I think we said that we did hydrogen, helium, lithium, and beryllium, and now we're going to do. Let's go ahead. We filled up the 1s, the 2s, and we have to now go to the 2p. I think that's where I was at. Let's go ahead and do. We're going to go ahead and skip, and we're going to do oxygen. Oxygen is number 9 on the periodic table. So it has 9. I apologize. Oxygen is number 8 on the periodic table. So we need to fill in 8 electrons. All right. So we come over here and we go to the 1s and we fill 1 up and 1 down. That's 2 electrons. It's filled. So we have to come to the 2s and we fill an arrow going up and an arrow going down for a total of 4 electrons. Now let's go to the next energy level, the 2p. And I need a total of 9, so I need 5 more. Well, I need a total of 8. So I need 4 more. So watch how I fill this in. On my 2p, since I need 4 more electrons, I'm going to put an arrow up, the next orbital arrow up, the next orbital arrow up. That's a total of 1, 2, 3, 4, 5, 6, 7, and then I go back to my first little orbital there and put an arrow down. The reason why I do that is it's sort of kind of like a rule. You have to have all the arrows up in that level first before you put the down arrows. All the spins have to be going the same direction to begin with before you start filling the other spin. All right. So as I look here and I want to write my electron configuration, make sure I have 8. I have 1, 2, 3, 4, 5, 6, 7, 8. That's correct. So my electron configuration is 1s2, 2s2, and on 2p I've got 1, 2, 3, 4 electrons. So my electron configuration there would be 2p4. Now real quick, let me go back here and notice on my 2p I've got 6 here. And sometimes kids get confused and they think they have to put a 6 in for that. Well, no, I didn't need the 2 extras. I only needed a total of 8. So I only needed 4 on that 2p. So that's why my electron configuration is 1s2, 2s2, 2p4. Now nitrogen, I apologize. Let me go to the next one, number 9, fluorine, which has 1 more. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Put another one down. That one would be 1s2, 2s2, 2p5. And then the last one on that period would be number 10, neon. Neon has 10 protons, therefore 10 electrons. So I just continue. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put 1 down, 10. 1s2, 2s2, 2p6. Now I wanted to get there because I want to show you what happens when that gets filled up. When my 2p gets filled up, real quick, back to this. When my 2p gets filled up, I go to my 3s. Sure enough, I'm going to my 3s. So the next period is sodium, and it has 11 protons, therefore 11 electrons, and I need to place them. Well, where do I go after this is filled up? I go to my next one, and the arrow goes up for the electron. And I simply continue adding on. 1s2, 2s2, 2p6, and then 3s1. Those are the electron configurations for those elements. Not hard at all. As a matter of fact, it becomes pretty simple once you know how to follow the diagonal rule. And once you know how many orbitals are on each sublevel. And then once you understand that the arrows go up first and then they go down. Okay, I want to do a larger one to get up to the D, the 3D. So let me see which one I'm going to do. We're going to do number 26, which is iron. All right. So number 26 is iron. Iron is Fe. We'll learn why later. But we need to place 26 electrons. All right. Now just looking at this diagram right here, we've already done a few. So we'll just go ahead and use it because I don't want to start over. So the 1s, I'm going to put one up, one down. It's fill. The 2s, I'm going to put one up, one down. It's fill. The 2p, I'm going to put one up, one up, one up, one down, one down, one down. It's fill. I'm going to go to my 3s and put one up and one down. So far I've got 2, 4, 6, 8, 10, 12. I need a total of 26. So let's continue on. On my 3p, 2, 4, 6, 8, 10, 12. Up, 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 down, down, down. That's filled up. Now I'm going to put it on my 4s. I'm going to go one up and one down. Now let me see how many I have. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I need 6 more. So I'm going to go to my 3D and I'm going to put one up, one up, one up, one up, one up. Let me count it again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, 22, 23, 24, 25. I'm going to come back here to this orbital and put a down. All right. So right now, this is my electron configuration for iron. I have 1s2, 2s2, 2p6. I'm running out of room over here to show you. I'll put underneath it. 2p6. 3s2, 3p6, 4s2, and then on my 3D I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So that's my electron configuration for iron. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, it seems long, but it's really not. What it basically is you're following that roadmap, the diagonal rule, and you're basically just writing down the electrons you fill in the suborbitals. Okay, one other thing we need to say, I need to show you, is a lot of times if we look at this suborbital right here, this is what we call a pair of electrons. On the 2s we have a pair of electrons. On the 2p we've got 3 pairs of electrons. Now if there's a one up and one down on that orbital, it's a pair. Let's come down to the 3d. On the 3d I have a pair. And then I've got these other ones by themselves on each little orbital. We call these single electrons. So I've got a pair and then 4 single electrons on my 3D. So a lot of times when I talk about a pair of electrons, this is what I'm talking about. On the orbital, you've got a one up and one down or a pair. If I say a single electron. I'm talking about just one electron on that orbital. Okay, guys, that's all for today. We'll see you. Well, you need to take your quiz, and then we'll see you on Monday. I'm sorry, Tuesday.